Hi, folks. As we continue our discussion of some essential chemistry that you might know, this is about acids and bases. Now, acids and bases are two very broad categories of chemicals. They are solutions in water. There are other acids and bases that are fatty acids, for example, but we're not talking about those. We're going to talk about the basic kind of acids and bases that are water solutions. Now, these are very, very common. Some of them are strong, dangerous. They can be hazardous and cause a lot of damage to people. And many are weak, and we eat them, we drink them, we wear them on our bodies, and we enjoy them. And primarily this time we're going to talk about acids, their properties, and some important acids, some common acids, and how we use them. So to begin with, one of the most important and obvious properties of food acids is that they taste sour. Citrus juice, orange juice, lemonade, grapefruit, things like that, acids taste sour. Vinegar, pickles, pickled jalapenos, those things have kind of that soury sort of taste. When milk goes bad, the acid content increases. Tomatoes are full of acid. Acids as a chemical are good dehydrators. When acids are added to something else, they have a tendency to chemically bond with water. And when something bonds with water and removes it from another chemical, that is referred to as dehydration. Just the same use of the word as if you have a food dehydrator because you're going to make jerky or dehydrate vegetables. Acids tend to shrink tissues. So one of the places that it is used is in a situation like hair products. For example, if you ever see hair products that say sleek and shine, well, hair molecules, or not molecules, hair itself is made of lots of little plates on the hair shaft, and these plates on the hair shaft can get frizzy. Well, if you put a very, very weak acid on them, what they'll do is they have a tendency to lay these down. And that's acidity that's just a little bit off from water, just slightly lower pH than water is going to make something shrink that tissue and reduce its size. Why and how does that work? It dehydrates it, takes that water molecules out of it. Some acids we're going to talk about are very dangerous, and yet acids are essential to life. One of the most important ones, of course, is amino acids, part of our DNA. And we've got some examples here, everything from the coffee that powers me on most days to aspirin, milk, vinegar, cola. They are everywhere all around us. Another collection of the properties of acids is that they tend to react with metals. Now, they can corrode metals. They can increase the rate at which metals rust. When acids react with metals, they tend to form hydrogen gas. So if you have acid, for example, sulfuric acid is known as battery acid, and if some of that acid gets on those terminals on that car battery, it can cause corrosion, and that corrosion is that chemical reaction of the acid plus the metal. And there can be a creation of that hydrogen gas if you do not have an enclosed battery. Sometimes that hydrogen gas can come out. Hydrogen gas is flammable. And I have heard from talking to friends who are mechanics that one of the cardinal rules is don't check the battery when you have a lit cigarette in your mouth. That's not probably a very safe thing. Acids, because of the fact that they react with metals, can be used for etching, decorative etching on metals. And because of the acidity of acids used in batteries, this is why you should take batteries out of appliances and electronics that you're not going to be using for a while, because the acid will actually eat through the metal components of the battery, and then those acids can attack your appliance itself. Acids can be very corrosive to skin and fabrics. Why? They dehydrate. They actually, again, they remove those water molecules. So this photo, there is a picture of cloth, just simple cotton cloth. Little sulfuric acid was added to it, just 1 or 2 drops, and it turns black. Why black? Because the water molecules were totally removed, and what's left is carbon, and carbon turns black. This is a demo that's real commonly done in chemistry classes. This is plain old ordinary cane sugar, the sort of sugar you would put in your tea or on your cereal. Sulfuric acid was added to it, and it removes all of the water from the sugar and it turns it into pure carbon. And that is a very dramatic example. If you ever get battery acid on your jeans, your pants, something like that, it'll eat holes right through them because of the fact that it will pull those water molecules. And you go, I don't have any water in my pants. Well, you do, kind of buried in those chemical bonds, and those strong acids can do this. If acid, you may have heard of people who have suffered from acid attacks. Yes, some people have spills and it gets on their body. This is a British model. Her name is Katie Piper. Many years ago in the early 2000s, Katie was attacked by a gentleman and he threw acid on her. She went through many facial reconstructions. She is now a speaker and advocate for and a spokesperson for people who have gone through similar situations like her. She's been through a lot, but this is the damage that can be done because of these very strong acids. Now, some of the important acids you may encounter in your life. I mentioned sulfuric acid. Sulfuric acid is the acid that's used in car batteries. H2SO4, commonly referred to as battery acid. It's also really important industrial chemical. It's used in the manufacturing of everything from rubber to fertilizer, explosives, paint, deodorant, detergents, things like that. Usually in the top 1 or 2 or 3 most important, most highly used industrial chemicals in this country every year, because it is so powerful. It can change so many other chemicals. So if we're going to make a chemical reaction, sulfuric acid can do it if nothing else can. Another important chemical or acid is hydrochloric, HCl. Hydrochloric acid is stomach acid. Your stomach is so clever. What an amazing organ. It produces hydrogen ions and chlorine ions separately. When you start the digestive process, you don't usually carry around a big pool of hydrochloric acid. It would be hard on your stomach. But when you start that digestive process, your body produces both of those ions and makes that hydrochloric acid as need be when it starts to digest. Now, you can buy hydrochloric acid at the local hardware store, and it's usually referred to as muriatic acid. Muriatic acid is a 30-ish% solution of hydrochloric acid, and what's it used to do? Etch concrete. Let's say you want to repaint your concrete steps. You've got a bad oil spill in your garage and you want to clean it up. Well, you can use that muriatic acid. You spray it all over. You let it sit for a few minutes, then rinse it down, and you now have a fresh concrete surface. How does that work? It basically eats off the top layer of concrete and you have fresh concrete below. And hydrochloric is used often in batteries, and that's one of the reasons that it eats through them. Another important acid is nitric acid. Nitric acid tends to produce, a lot of nitrogen compounds tend to produce yellowish brown things, like we talked about smog in other videos. Nitroglycerin is one of those products that can be made with nitric acid. A lot of fertilizers, a lot of explosives are made using nitric acid. If you smoke, or if you have friends and family that smoke, there's very often kind of yellowish stains that occur, and that is because of nitric acid stains. Phosphoric acid can also be used as a cleaner in a very weak solution of phosphoric acid. It can be also found in some soda pop. There are a bunch of weak acids, weak meaning they're not terribly reactive, not as dangerous as sulfuric or hydrochloric, but these are part of our everyday life. Vinegar, acetic acid, vinegar that people use for everything from pickling and pickles and to just do everything from cleaning to cooking and making salads, is a very, very common and tasty acid. Carbonic acid, soda pop. Carbonic acid is made by taking carbon dioxide and just bubbling it through water. If you ever go to a fast food restaurant, they have water and they usually have CO2 canisters somewhere near their fountain, and then they have the flavoring of whatever your favorite pop is, whether that be Mountain Dew or Pepsi or Coke or whatever, and they mix the CO2 and the water and the flavor right there. They don't keep the liquid on hand. They keep the water and CO2, and that's one of the reasons why fountain drinks taste different in Wisconsin versus Texas versus Oklahoma, because they're using local tap water to make those drinks. Lactic acid. Same root word as lactose. Lactose is milk sugar. Lactic acid is the acid that is found in milk. Plain old ordinary, beautiful, fabulous milk contains a small amount of acid. It's slightly acidic, and that's one of the reasons that milk is refreshing to drink. Lactic acid is also naturally produced in the body when you exercise. And when you start to get that fatigue in your muscles, a lot of that fatigue is that buildup of lactic acid. So during that cool down period after you've exercised, one of the things you're doing is you are actually working that lactic acid back out of those muscles. And you've got to work long enough to give the body a time to flush that lactic acid out of the muscles. And that prevents you from being as sore. Citric acid is citric fruits, apples, oranges, pineapple, lemons, things like that. If you want to be all nerdy, if you have a headache, you don't say, I want an aspirin. You say, I am going to go take some acetylsalicylic acid. Okay, can you say that with me one more time? Acetylsalicylic acid. It's fun to say, isn't it? That is the fancy name for aspirin. So those are some common weak acids, the sort of thing you are going to find around your home. And that will do for this time. We're going to come back next time and we're going to talk about bases. See you then.